time does AT&T have? Does anybody have AT&T? Does anybody have AT&T? What time does AT&T have?
11:55.
11:55. Verizon's 11:55. How's the head?
Good, 100% now. So.
That had to be so surreal.
It still is thinking about it, but
When I saw the explosion, I was just like, and you said you were how many yards from that?
like probably 15 yards, 20 yards away. Yeah, it's pretty close. It was definitely.
That mean,
Same
yeah,
thing,
did
yeah.
it, so did it blow you off your feet?
I felt like initially I felt glass hit my back, and then I felt that blast feeling. Yeah. But it did knock me off my feet. It knocked some people off their feet though. So some of the lineman people who were smaller got knocked off their feet.
But nobody got hurt in the ROTC group, right?
No. Only one. I think one person had like a small fracture in their leg, but that was pretty much it.
That's a miracle.
It is definitely a miracle.
That's. So yeah, I was hoping to get Quest back today, Quest 3 back today. It is Quest 3, right? So you're taking Quest what, 4? 4, okay. So as far as other quests, there'll be one more quest, not next week, even though technically it would be more like next week. It will be the week after Thanksgiving, week after break, okay? We're gonna have that quest, and then we're gonna have our final quest, our 6th quest on final exam day. Does this make sense? Does this make sense? For the first time, I'm not giving a cumulative final exam. I've never not done that. I started teaching in 1984. How old were you in 1984? 0. So I've been teaching 1984. Okay, 16 plus 20 is 36 years. I've been teaching 36 years, and I've never not given cumulative finals. Okay, but this semester I'm not giving cumulative finals. Just because this semester has been stressful enough for you guys. I mean, you're learning, a lot of you guys are learning through videos or Zoom where you're barely able to even see the board. And all your classes, you know, everybody's sending you video stuff. That's just miserable to look at, things like that. We'll just take a little chunk at a time. Are you okay with that? Are you okay with that? Now, as far as calculating your grade, you've got your WebAssign, which counts, I don't know, 15%, something like that. It's on the syllabus. We're not doing a final project. We're doing a final quest, okay? And then what we'll have then is we'll have how many quests? 6, okay. Each one of them, even though they're worth separate amount of points, I'm going to scale them all to be worth 50. And so you'll have how many quest points altogether? I know this is hard. You're taking calculus tests. Okay, how many quest points will you have? 300. So then you would calculate how many points you got and then divide by 300, and that would be your quest average, and that would be worth 85% of the course. And then you've got your 15% for doing your homework, your WebAssign. Now, guys, if you didn't do a WebAssign, that's homework. That's homework. Send me. Tell me you didn't do one. And I'll probably open it up for you. There might be a small penalty, but I'll open it up for you. So if you're like, Dr. Warren, I'm falling way behind on WebAssign, well, just let me know. It's homework, okay? So it's not like taking a test. Does this make sense? We all in the same. So I'm hoping to get Quest 3 back to you. On Monday or Tuesday if you come to class. Definitely Monday, maybe Monday. We'll see. Monday and Wednesday. the one person's supposed to take it on Monday before class, I think, so I should be able to return them. They're graded. And then I'm hopefully going to get back the other one next Friday, the last day of class. You'll have a WebAssign due on Friday by midnight. How many people are gonna go home for Thanksgiving? Okay, how many people are staying home after being home for Thanksgiving? Okay, a number of people. So let me get on my podium here. Yeah, there we go. Okay, okay, on Wednesdays, you can get a free COVID test, whether or not you're sick or not. Where? UPark, a free COVID test. What don't you want to give for Thanksgiving? COVID, yeah, you don't want to give side dishes of COVID to grandma and grandpa and everybody like that. So it would be a reasonable idea to go to UPark and get your COVID test on Wednesday, and then you could come and get back a Quest on Friday, and chances are you'd get your test results back also on Friday. And if you test positive, okay, then guess where you're not going for Thanksgiving? Home. Does this make sense? Okay, let me know. I will bring turkey to your house or wherever you're at. I will bring you turkey, okay? But you're not going to give side dishes of COVID for Thanksgiving. Are we all on the same page? Okay, all right. Okay, you have a what today? Quest. Okay, I'm going to give you 30 minutes, so that means I need to stop when? 12:20. Verizon, when Verizon says it's 12:20, and so it's 12:02 now, I bet if we get a second remote, okay, stop. All right, like phones. Okay, I guess this helps you kind of for the quest a little bit. E to the anything is greater than 0. E to the 0 is 1. If f of x is e to the x, then f prime of x is e to the x. If e is pregnant with another function up in its exponent, the derivative of that is e to the f of x. Just write it down again, then times f prime of x. How many will know that? And feel reasonably prepared for heading into the test? Chances are you're going to need to know that. Okay, now, we didn't talk about this, but what would the second derivative of e to the x be? E to the x, yes. The third derivative? In fact, all of the derivatives would be e to the x. But we can use this to really help us understand what the graph of e to the x looks like. We know at 0, we know when x is 0, e to the x is 1. E to the x is always greater than 0. So it's greater than 0, which means it's up here, not down here, never touching this line. We know its first derivative is positive, and again, this helps you for your quest. The first derivative is positive and always positive, and what does that tell you about the function? It's always increasing. Not only that, its second derivative is also positive, which tells you what about the function? Okay. It's always smiling. So I want to draw a function that's always smiling, always increasing, and goes through this point. Well, if it's always increasing, that means when I'm coming in, can I be up here? No, I've got to come in, I've got to hit here, and then I've got to keep increasing, and I've got to always be smiling. So we have this horizontal asymptote, and this is like our graph of our e to the x. Have you guys seen a graph like that before? It's our standard exponential function. E to the minus x is just the opposite. It swings in like this. Okay. Does this make sense? Okay. Now here's the thing. If functions are always increasing, or if functions are always decreasing, they have a very special property. go, Dr. Warren, what is that special property?
What's that property?
What is that property?
So many Lorelei. So ask everybody in class, okay, as a choir.
What
What
is
is
that
that
special property?
Aiden?
What is that property?
Okay, what is that property? I'm glad you asked, okay? It means there's an inverse function. Say that.
There's an inverse function.
Okay, and you're like, well, Dr. Warren, why are inverse functions nice? Okay, they're nice because, let's just say that Dr. Warren had a friend at
JMU.
JMU, okay? And let's just say that they decided it would be a good idea in February to drive down to
New Orleans.
New Orleans, okay, and discover what Mardi Gras was about. Okay? And let's just say this friend's name was, hypothetically, Rich, okay? Okay, and Rich was very much a genius, very much a gentleman, okay? But we got down to Mardi Gras, there was a bus that we took, okay, B for bus, okay? And we got down to Mardi Gras, and guess what happened? Rich, yeah, well, you really don't want to know what happened, okay?
I do wanna know now.
Rich, well, I didn't realize that when Rich drank, Rich changed, okay? Rich became angry Rich, okay? Uncontrollable Rich.
Like the Hulk.
Like the, yes, like the Hulk, okay? So I go out to just walk around. I come back and all of our suitcases are on at the front of the hotel. And I'm just like, what in the world's going on? And then I find out Rich had been drinking, okay? They brought up our suitcases and Rich attacked the bellhop, okay? He pushed the bellhop onto the bed. Then I found out Rich was in his underwear, okay, and had the bellhop on the bed, okay? And I'm just like, you've got to be kidding me. And this was our start. This was our start to Mardi Gras. This was our start to Mardi Gras. So what we have here is that under the function bus, our JMU Rich, who is such a good student, such a nice guy, down in New Orleans became
The Hulk.
the Hulk. Well,
Angry Rich.
yeah, Angry Rich. We'll draw him in his underwear here. Okay. Okay, and attack the
Bellhop.
bellhop. Okay. Now, is it good there's an inverse function? Was it good for Rich there was an inverse function? Yes, because an inverse function can undo what a function does. How many people rode the bus to school? How many people had that nightmare? Okay, if you didn't have that nightmare, you weren't really ever in school. You know, I went to public school, and all I ask is, did you ride the bus? And then, if you did not ride the bus in high school, then you did not go to public school, because public schools are divided into two different things. There's the kids that don't go to college, that they're just hoping will get a degree. Then there's the kids going to college, and there's almost like two different schools. There's like an elite prep school inside the public school, especially if you live in Northern Virginia. Okay, it's like an elite prep school. And then you've got the kids that are just barely going to survive, okay? They're just taking their pulse. Sorry, I'm recording this. Okay. All right, but if you did not ride the bus to school, you did not go to public school. Okay, how many people rode the bus to school? And how many people were glad at the end of the day there was a bus to bring them back home? How many people were like, okay, thank goodness there was a bus to take us back home? How many people rode the bus for more than 30 minutes? How many people had a bus ride longer than 30 minutes? Yeah, you're a county kid, aren't you? Yeah, okay. Yeah, okay. So here's this bus. Takes Rich to New Orleans. He becomes
Angry Rich.
Angry Rich. But thank goodness there was a bus, a Greyhound bus, you don't even know what that is, that we're calling the inverse function, that came along and took
Angry Rich.
Angry Rich. Underwear. Back to JMU and
Nice Rich.
Nice Rich. Yeah, I mean, like, does anybody else know an Angry Rich? Does anybody else know somebody who looks completely? You guys have never drank. Sorry. Hey, a friend who like gets alcohol and you're like, whoa, I did not expect that. I can see how some of you are honest. Okay, yeah, okay, that's all right. So what's the job of the inverse function?
To take Angry Rich
Okay, in general, what's the job of the inverse function?
To undo the function.
Undo the function. Look at somebody and say that without breathing on them. What's the job? What's the job of the inverse function?
To
Undo the function.
Okay, how many people have an Apple computer? What's the undo button? Like if you type something, you're like, oh, I screwed up. What do you how do you undo that? Command Z. Okay, in Windows machine, it's Control Z. How many people are glad there's a Control Z? How many people have used Control Z? Don't you wish there were Control Zs for relationships? Don't you
Yes.
wish there were Control Zs for relationship? I mean, like, how many people have been in a relationship before? Okay, how many people have said something and wished at that moment there was a Control Z that would undo what they just said in that relationship? Okay, so in order for there to be an inverse function, the function needs to either always be
Negative.
What do you want?
I said it earlier. I want to see if it sat on anyone.
To undo the function? What?
Oh, bless your heart. Say it again.
Always be increasing.
Stand up, stand up, stand up. What's your name?
Hannah.
Hannah, just yell it to them.
Always be increasing.
It's okay. Let's give it up for Hannah. She's up there. Or it could always be decreasing. As long as it's always increasing or it's always decreasing, there will be a Control Z function. A function that can undo what the function does. Is it nice to have a bus to take you home?
Yes.
Steve, you didn't go to public school, did you?
Yeah, I did.
Okay, okay.
Sorry,
No,
I'm like,
did you ride the bus?
in middle school, yeah, but in high school, I just had to walk out of my back gate to go to school.
Oh, okay. Was this Northern Virginia?
Yeah, Virginia Beach.
Walk to school. Oh, that's okay. Look at e to the x. Is it always increasing?
Yes.
Then it has to have an inverse function. It has to have a function that can undo what it does. Now guys, in order to make sure that you've got an inverse function, you have to pass what test? Nope, that's to test if you have a function. You can't ever have it hit more than one value. What's the definition of a function? I hate you, Dr. White. That's not the definition. A function is a relation that assigns to each set a unique value in a second set. So if you, I can tell it. Stand up, stand up, stand up. We're not passing COVID around. Smack your face, smack your face. Say, wake up, you're gonna take a test. Say, wake up, you're gonna take a test. I got chalk on my hands. Wake up. The thing I do for you. Okay, sit back down. For the inverse function, the domain of the inverse function, say that, is the range of the function. Let's try that again. The domain of the inverse function is the range of the function. So the domain of e to the x is this, the range is the y-axis. The domain is the x-axis, the range is the y-axis. So the range of the domain of the inverse function would be the y-axis. And so if e sends 0 to 1, then the inverse function would send 1 back to, so if this bus sends 0 to 1, then the inverse function would send 1 back to 0. Does it have to have, does it pass the horizontal line test? Does e to the x pass the horizontal line test? Does it only cross in one, with every horizontal line only cut it in one place? So e to the x has a inverse. There's a function that can undo what e to the x does. Okay, so if E sends apple to banana, then what should E's inverse do? What should E's inverse do? send banana back down. Is this making sense? Is this making sense? Now let me tell you who E's inverse is, and you're not gonna like it. You've never liked this function. You've never liked this function. Does anybody know who E's inverse is? It's log. It's log. It's not just any log, it's the natural log. So say that. Say that again. Does anybody remember what function we use for the natural log? Does anybody remember how we talked about the natural log? ln of x. That's the natural log. And so, who's natural log's inverse? E to the x. Who's e to the x's inverse? Okay, let's try this again. Who's natural log's inverse? Who's e to the x's inverse? So who can undo e? Who can undo natural log? Who could undo Rich? Greyhound. How many people are following? Because I don't want this to be complicated. Steve, are you with? Just make sure. 5 minutes. Just to get this relationship. So if E sends, give me any fruit. I'll draw any fruit you want.
Grapes.
Grapes. E sends grapes to any other, what number do you want? What number? Something that represents a number.
7.
Okay, not 7. I mean, not a number. I need something that's visual. Okay. Something you eat for Thanksgiving.
Turkey.
Turkey. Okay. Well, why did I pick a turkey? You're like, thanks, Dr. Warren. So if E sends grapes to Turkey, then natural log better send turkey back to grapes. Does this make sense? Okay, so now, how many people don't want to draw turkeys and grapes? How many people don't want to draw turkeys? So give me a letter for turkey.
A letter for turkey.
T, okay. Give me a letter for grapes. G. So another way of saying this is that E of G is equal to T, and natural log of T is equal to G. How many people are following? Okay. Now just look, read. E to the is natural log of is G. See, I make this next move every single time I teach Math 205. And to me, it's just so obvious. And then I look out at my students, and there's like half that don't understand. And I'm like, no, what are you not getting? Well, how have I failed you? And so now I'm going to try one more time. I'm going to try to bring all my little antelopes. How many people realize in those nature documentaries you don't want to be the last little antelope crossing the Crocodile Creek? How many people just like know that little antelope, you just know nothing good's going to happen? The first